Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
All right, so this one could be a little bit tricky because it says compounds or ions. So we're kind of going to have to take a guess at what the charge is. Compounds would be neutral, and ions could be positive or negative. So what we're going to see here is whenever we have a bromine with an odd number of fluorine atoms, we'll have an even number of electrons, and we won't need to introduce any sort of charges to it to make a molecule that makes sense. Whenever we have a bromine with an even number of fluorine atoms, that'll be 2 and 4, we'll need to put a charge in there, or we'll have an electron that's all by himself. So let's jump right in with the first one, BrF1. So bromine and fluorine each like to form one bond. So that's really easy to do because they have 7 valence electrons. It looks just like this. It looks sort of like Br2 or F2, but just one or the other. So this is going to be sp3 hybridization, and it's also going to form a linear compound. For BrF2, we're going to encounter this odd number of electron issue first. So if we fill out fluorine's electrons, like this, now bromine has 7 valence electrons, 2 of them are tied up in bonds. So we have 5 left over. If I put this 5th one in here, we see that we have an odd number, and we've also violated the octet rule. So we're going to instead remove that and just go with BrF2 plus as our molecule. Since bromine can expand its octet, it could be a reasonable guess to also try BrF2 minus. You'll get a different geometry than what I do, but it's still a valid structure. So for here, again, this is going to be sp3 hybrid, and it's going to form a bent structure. This is analogous to water here, where you have an oxygen with 2 electrons and 2 bonds. For BrF3, what we're going to see is our first time that we have to expand our octet, because bromine, again, has 7 valence electrons. If we use 3 of them to form bonds, we have 4 left over, which will be 2 pairs, and that's 5 total things around it. So we can't do that just with sp3, sorry. We had to include an extra orbital, and that's going to be the d orbital, because it's the next lowest in energy. This is also going to form a T-shaped type geometry. It bridges off, its electron geometry is the trigonal bipyramidal, but because 2 of them are lone electron pairs, we only see a T shape. For BrF4, we're going to again need to introduce either a positive or a negative charge. We'll see that since bromine has 7 valence electrons, if we form 4 bonds, we're left over with 3. 1, 2, 3. On the bromine, since it's already violated the octet rule, I'm going to give it an extra one. This will be BrF4 minus. That's also going to have sp3d2 hybridization, because it's got 6 things around it. We need 2 d orbitals. And its electron geometry, whenever you have 6 things around it, your electron geometry is always going to be octahedral. Since 2 of those are missing, we're just going to be left with a square plane, which is sort of what I've drawn here. If you imagine these electrons being on top and on bottom of the bromine, coming in and out of your screen. And finally, we have BrF5. I'm not going to draw this one. I'm going to do the Lewis structure, but not the geometry drawn, since it's hard to draw 3-dimensional things, especially with this app. So what we see here, since bromine has 7 valence electrons, 5 of them are used up in bonds, that leaves us with 1 pair left over. It's a total of 6 things around it, so we need sp3d2 hybrid orbitals. We're also going to have the same electronic geometry as this guy, the BRF4. But since we have an extra fluorine, we're now going to form a square pyramid instead of a square plane for our molecular geometry.